Objective 3 of 2.2. We have more transformations now. Reflection, stretches, and shrinks. The graph of y equals a times f of x. F of x, some function, now is going to be multiplied by a number a, can be obtained from the graph of y equals f of x by multiplying each ordinate value. Let's call that a y value. How about that? Each y value of y equals f of x by this number a. Now, sometimes a is greater than 1, so you're multiplying the function by a number greater than 1. Now, what if the thing multiplied by a number greater than 1 were your salary? If your salary is multiplied by a number greater than 1, that's a good thing. The result is a vertical stretch of the graph of y equals f of x. But suppose your salary were multiplied by a number less than 1. A number like 1/2, which is between 1 and 0. That would be a bad thing. The result is a vertical shrink of the graph of y equals f of x, also known as a vertical compression. Well, another kind of transformation, it's really the same, but if a is -1, if you multiply a function by -1, the result is a reflection in the x-axis, because all of the y values, now they're going to be the negatives of what they were, and that means that points above the x-axis are going to be below. Points that once were below the x-axis are going to be above. In other words, there's a reflection in the x-axis. And so here's a problem. Y equals absolute x. Y equals 2 times absolute x. 2 is a number greater than 1. Y equals 0.5 times absolute x. And y equals -2 times absolute x. So take a moment to think about how each of those 4 graphs will look. Is that what you thought you'd see? Okay, y equals x, that's the parent, and that is the black graph. That's the parent function, and the others are the offspring. 2 times absolute x, there's your vertical stretch. So function, the black graph is stretched vertically, meaning you have a narrowing of the v. Okay, a narrowing of a v. Now if you have a vertical shrink, then that's a widening of the v. And that's what we have here. Y equals 0.5x. You're multiplying by a number less than 1. Well, if you multiply by a negative and a big number, like -2, that's what happens in this 4th problem, then you're going to have a narrow v, like y equals 2 times x. But of course, everything's going to be reflected downward through the x-axis. So you're going to get points like 1, -2, 2, -4. And so your graph will look something like this. And this. Something like that. So there was a vertical stretch and a reflection through the x-axis. Summary of transformations. We first had translations or slides, and that was adding a number to a function. Okay, adding. Okay, and that was the previous video. If you add a positive number, you get a vertical shift upward. If negative, downward. Then we had horizontal translation. That was adding on the inside of the parentheses. Or replacement. This is again the previous video, and I encourage you to think of it as the replacement of x with x plus h. When you have that sort of replacement, then it's a horizontal shift. That's not what we have up here. Okay, that's not replacement. That you're just adding a number to a function. But down here we are replacing, and the result is a horizontal shift. Again, the opposite direction of what you'd think. That was the previous video. Now in this video we learned about vertical stretch and shrink. F of x is now multiplied, not added, but multiplied by a number a. If that number a happens to be -1, it's a reflection through the x-axis. If it's multiplied by a number greater than 1, vertical stretch. If number less than 1, vertical shrink or compression. So that's a lot of info and not necessarily all that easy to absorb. But here's a poster that you might benefit from referring to. And it shows the transformations of y equals x squared. So, you know, it's just a bunch of transformations on the parabola, upward opening, vertex at the origin. A simple function with simple transformations, simple examples of transformations applied to y equals x squared. Now we'll get it done for objective 3.